development engineers? How should they plan it out?
Yeah.
Foster it maybe?
I would say a big piece of advice for everybody, whether they are an engineer, a engineering leader, or a product manager, or even the person in charge of the whole organization, is kind of first orient yourself if you are in the right place for this sort of stuff to happen. So let's say what I mean by right place is something like a startup or a scale up or a company that has traditionally done a lot of this product-led engineering, where you can actually, if you want to do this stuff, even if you're not doing it, people are going to help you to achieve that stuff. If you're not in such a place, if you're perhaps working very far away from the customers, if the domain is very complex and you have no hope of actually understanding it, you're working on rockets and you're not a rocket engineer, so it's not gonna work out. You kind of have to be realistic and say, probably in this place, I cannot become a product-minded engineer, or I cannot turn my team around to be a product-minded team, because there's just like the context is not okay. But if you do this sort of stuff, if you find yourself in such a place, then I would definitely start from, as an engineer, understanding, figuring stuff out, and then asking for a seat at the table. Then if you're a leader of such a team, you're going to find some people absolutely want to do this stuff and they get energized by it. Other people need more sort of encouragement, and you should absolutely start with the first group of people and get them to operate at that level, get them to have opinions, empower them, give them access to documents, give them access to forums where this stuff is being discussed, and sooner or later you're going to start seeing them actually change their mindset from, hey, wouldn't it be cool if we had this thing, to, hey, we have a feature, is anybody else going to use it? Can we build a sort of impact model for it? Can we have like a launch plan? And all of these product-minded discussions. And once you have some sort of people doing that, others will follow, essentially. There might be some hardcore people who don't want to operate like that, and that's fine. Like, you probably don't want 100% of the workforce to be like that, but even if you have 2 or 3 engineers on the team that are operating like that, it's just massively empowering for the whole team. That's going to lead to better results, or nice goodies down the line, essentially.
Makes sense. Talking about like the Stripe being US based, what do you think is the difference currently between US and like Central Eastern European product and engineering culture? What should we be aware about?
I would say there is this saying that I don't know exactly who said it, but it's very true, that there is a lot of Steve Wozniaks in this region, not a lot of Steve Jobs. So it feels that there's many people that are technologists and they're very much into technology, not so much into problem solving. Now, we do have the notion of product-minded engineer that's coming from the US, so it is a label for a concept that exists there. It's not that there's 100% product-minded engineers, otherwise they just would not have the concept. So the ratio, I think, is the thing. There's just many more of these engineers there than there are here, and we can just work to shift this ratio by engaging more with startups, kind of trying to engage more with problems, and doing all of the stuff that I mentioned before. I think it is a really big inflection point nowadays for our industry, and this is a big lever we actually have to change the trajectory for where the IT industry is going in Romania and the broader CE region in the next couple of years. Just solving more problems, focusing less on technology, if you will.
Yes, definitely moving from services to products. We've seen that across CE, across the Balkans. A lot more local startups have created the opportunity to work on products.
Yeah. Keep in mind this was like 2013, so nobody knew about the cloud. And I got to the founders and I told them, like, this is the perfect use for the cloud. We have really big spikes, we can scale, and then when nobody's online, we can just scale down. And they said, okay, makes sense. Do you know how to do it? And I was like, sure, why not? We're gonna find out. The only choice was, of course, AWS, which we started to migrate on. And in that time, since I wanted to do a full page cache, but to do it properly, to do it fast, because any app that you have, if the cache in the app, it's slow, because you have to boot the whole app. You have a dedicated piece of software that can do that for you. It's called Varnish. If you're going to remember anything from this talk, it's this. This is the single most important piece of software that we have, and it's free. It's open source. It basically acts as a reverse caching proxy, so it will respect your HTTP headers, cache everything ultra fast. does request coalescing. It solves the problem I was talking about earlier, because if you get thousands of requests, it will only allow one request to go, everything else will halt, and then when it gets a response, all of the users will get the same response. So you get really low impact on your backend service. Now, when we moved to the cloud, this was a pretty basic standard thing. So we had an auto-scaling group, we had our app, we had a database, we had workers, we could get rid of memcache because it wasn't no longer necessary, and it was working really easily, it scaled. The most important thing to do when migrating to a cloud, or when developing a new app for the cloud, is you have to be stateless. So if you save something to a file on a virtual machine, you're going to have issues, because you're not going to be able to scale. You should do this from early on. So when you write your first app, just don't write anything to disk. You don't want your containers, machines, whatever, to have state. In that time, we will actually look into experiment with new technologies. We found MongoDB because web scale, and we migrated everything to MongoDB because it worked as it should for a couple of months. Then we started to see issues with MongoDB. Anybody here who uses MongoDB, you might know what I'm talking about. So, I mean, we had a lot of different issues. We had replication issues. We had data type errors where integer and long integer are not the same. It was difficult to analyze the data. It was also, locking was really poorly implemented in those days. And we do a lot of updates, so you have to do a lot of locking, and then everything breaks. And also, no support for foreign keys. And this is everything that is important to us, because we basically analyze data. MongoDB, poor choice. So we said, okay, not the greatest decision we made, we have to change it. We found Postgres. This is what we're using today. In my opinion, it's better than MySQL if you ever need to do a relational database. Why? Because it's open source, it has advanced SQL capabilities which are really important to us, it has minimal locking, it has this cool mechanism called MVCC, multi-version concurrency control. Could be a whole talk just about that. Important thing, works, you can read and update at the same time, no locking. It has great performance. It has such a big performance that we actually don't need anything else. So we can do 1 million queries per second and also 90,000 transactions. Also at this time we had queues. This is something that's really simple. It was invented decades ago, but today everybody wants to use microservices. Microservices are hard. If you don't have a big enough team, you probably shouldn't do it. This is the simplest thing to do, and it works great. We have hundreds of different jobs that we do via queues. We use Beanstalk, any queue works. And it's important to queue everything that is slow, because then you have a big surge of traffic or things that you need to do. If you queue them, you can just hold them asynchronously.
So this is Martin Fowler, right? This is Martin Fowler's definition, and this is his short definition, right? This is, he probably has a longer one, I don't know, but so this is all this stuff that you need to take into account if you are thinking about doing microservices, right? Then there's a bunch of questions you need to ask, and I'm going to try to answer those for you, right? So we'll start off with saying, well, okay, when would you do this and when would you not do this? That's one point, right? And then we need to talk about a little bit about architecture, because it is an architectural style. And then we need to talk a little bit about what I call micro applications. It's not the same as micro frontends, but I'll try to explain that briefly during this talk, right? And then we have to try to figure out, if you have a business domain, how are you going to break this down into something that fits the microservices paradigm? Well, I have some guidelines for that as well, and I brought it with me. And then, of course, continuous delivery is this point that if you are doing microservices, you never have microservices without continuous delivery, in my opinion, and in my experience, basically. So that means that every time we have a change in our code bases, we just push it to production all the time. And we can do that more easily because of microservices. So that's one of the benefits. There's also a lot of drawbacks, right? Like the total complexity of the thing. And then, of course, when you do continuous delivery, you need to talk about testing, right? If you are still doing manual testing, that's out of the question if you do microservices. And I'll try to explain why and how to solve that. And then, of course, there's the whole thing about who owns the data. Do the microservices own their data? Is there a central database? Is the application holding the database? All those questions. And then the last question is, does it actually change the way you work? And the thing is, it does actually. So it's more like, if you want to change the way your company works, microservices might be an idea to help you get around it. It's sort of like, well, it's chicken and egg, right? I'm not sure which came first, a different way of working or microservices or the other way around. Actually a programmer, right? To prove to you that I'm a programmer, look, I am actually double object oriented. There's nothing, my parents made this up, right? So it gets worse. I live in Amsterdam, but I live in a Java street. Who does that, right? So it's basically because they didn't have a TypeScript street in Amsterdam, so I went into, this is actually a picture from my window. So I also run this open source project called Easy, which is our TypeScript open source library for doing microservices. Please start it. We haven't done that many stars, but it's really nice. So let's say that's the problems that you can solve with microservices. I'm going to give you 2 real-life examples of companies that went into investigating microservices and for what reasons, because the reasons can be very varying. So let me give you some examples. This is the office building of an insurance company. I became their CTO in 2014, I think, and they had some interesting issues. So they had a mainframe. Have you ever seen a mainframe? That's like, they're huge, right? There's like, my MacBook is like, probably has the same computing power, but it is, this is big. And actually, this insurance company, the machine is on the 4th floor of the building, because in the Netherlands, most of the country is below sea level, which means if we flood, will happen sometime, I guess, then they don't want the mainframe to be in the basement where they usually are, so they put it on the 4th floor with a secret access to it. That was one of their problems. The second problem was that they had 18 million lines of COBOL and 12 million lines of Java, and they wanted to get rid of it. The reason that they wanted to get rid of it were their programmers, because their programmers were getting older and older, right? They wanted to retire. Actually, some of them did retire, and then they had to hire them back for very large amounts of money, and they only worked for 3 days a week, which was a good deal for the developers. So run COBOL, please, right? That's the good thing. So I'm not saying copy our architectures, it's just an example, right? So this is a book I wrote. It's in Dutch, so you won't be able to read it. It's a difficult language, don't worry. So I wrote this in 2003, I think. But in the book, it's sort of like the prototype of the architecture that we still use. So it always starts with the domain, right? This is domain-driven design. I'll talk a little bit more about that soon. And it starts with the centerpiece of it, so it's basically the entities. Right? This is the core of your domain. This is what defines your domain. It's the behavior and the state of the entities that actually matter the most. So every service has that at its heart. Around it, we have stuff like repositories. Right? Repositories are, it's a pattern from the domain-driven design book. They're there to get instances of entities for you and to push them away again into whatever you store this stuff in. Right? It doesn't really matter much. On top of that, we have what we call a process layer. That sounds horrible. It's not as horrible as it looks like. We define stuff in use cases, we model them as well. They're very small objects in the microservices that hold the process logic. So if you have multiple repositories bringing together behavior, that's what the use case does. They also handle the security and stuff, and it's very simple. On top of that is the resources, right? This is where you come in if you call an endpoint, it goes into your resource class, and the resource class distributes it through the use cases into the repositories. And on the bottom part of it, we have stuff going out, because you need to go into a database, into another service, into an external party, an external API, whatever you might have. We're trying to hack into our HR system. HR doesn't know that yet. Well, they might know if they are looking, but they're probably not. So we're hacking into the HR system to get the data out of who is somebody's manager. And our profile service does that actually. So you can put stuff away in different places. So Bob Martin gives a good clue, right? In the single responsibility, he basically says this. Gather together the things that change for the same reason, right? This is high cohesion. And separate those things that change for different reasons. That is low coupling. It's still the same, right? Over the history of computer programming, and I know I'm an old guy, so I've seen all this stuff in action. And it's like single responsibility is easily recognized when you break it. So this is a Python, it's a piece of Python code from one of our older applications, and it has over 350 lines of code in there. which means it's fairly big. You might say, that's not big, but I think it's big. You can recognize it because it does a whole lot of different things together in one piece of code. For microservices, you go back to the domain-driven design patterns. So this is the bounded content. Have you heard of, are you familiar with domain-driven design? Please say yes. Thank you. So one of the foundational patterns in that is called the bounded context. Now, this is more or less what Eric Evans, the author of domain-driven design book, says about it. He says, when you model larger domains, and you probably all do, it becomes progressively harder to create a single unified model. So keeping your data model in shape when you have 1,100 tables in there, as one of my customers has actually, is pretty tough, right? So what he says is you might be able to break that down into several different areas. A set of patterns from the domain-driven design. And we said, okay, here's the aggregate pattern. So the aggregate pattern in the book, as Eric Evans says, an aggregate is a group of associated objects which are considered one unit when it comes to data changes. We're like, oh, a transaction. Could be, however, we're using databases that don't have transactions. And transactions over services are pretty hard. So that is basically why, let's say the transactional boundary is a very good idea of splitting this up. And then he says, every aggregate has a root. Now if you look at microservices and they have an endpoint and a resource class to it, it's very easy to map an aggregate with its aggregate root onto a microservice, right? So if you have the categories, we call it a collection in MongoDB. I was just working on that, so we have the categories collection, and it has an idea. So if you want to get out the categories, say /categories/ID, there I go. And I enter into the aggregate root of that particular service.
To the potential users of your product. If you do that, the product will just become a bunch of everything. Its mission will not be clear anymore and most probably will not remain the same. It will try to solve lots of problems, but one of the definitions of the product I like is that a product solves a real problem without bringing other problems to whoever bought it. So it's really important to stay focused. Again, selling services, the more features a client wants, or the better you convince them they want more features, the better for you as a business, because you build more features, more revenue. With the products, sometimes success is in simplicity. The less is more, and it's not just, a cliche. Technology versus market, what does that mean? In services, the technical capabilities we have in a company are most critical. With them, we attract clients, with them, we sell, with them, we deliver. That's also important for products, but it's much more important, the market fit, the user group, the personas you identify. So here also it's a more subtle shift that needs to happen.
To look at popularity. The second one is content, right? What should you write? What should you be found on, right? And this is, spoiler alert, not using ChatGPT, right? Please don't. Right, and the third one is the indexability, the UX. In order to be found, people need to understand and engage with your content. Very simple. So, on all of these different ones, I'm going to give you free tools to get the information you need. And some of them are actually better than paid tools. Okay, first one, GA4 for SEO. Who's using GA4? Who hates it? Hands up. Yay! Agreed. But we have to live with it because it's free and people have it, right? So what is a must-have report for SEO in GA4? It's a very simple one. You look for the page title, you look up your page title for a 404 page, then go into GA4 and search for that. And then as a secondary dimension, you use source medium. There we go, right? So this is very important. And what happens if you do that? So this is, in this case, a scale-up that I'm a shareholder of, so I can share this. You see the 404 page title, right? And then you see the page path and query, and the session source and medium. What's really weird, this has uncovered that we're paying for clicks going to a 404 page. So in this case, it also helped me save money because I was actually sending paid traffic to a page that 404, right? So what do you do with this, right? So here you see it. That's the page, Google CPC, 24 users, so but 170 clicks times about £1 a click. This means 170 pounds in about a week's time. Not good. So what do you do with it? You 301 redirect. Or, in this case, you find the traffic and you fix it. Right? Very simple. Saving money. We get the thing, but we can't see cannibalization, we can't see any of the other things. And you can link the sheet with Google Data Studio, or Looker in this case, and you'll get like endless possibilities with multiple filters in the query filter, the page filter, so you can do all of it. If you have a bigger site and more data, what should you do? Don't use the native connector in Google, the Google Data Studio, because that has the same flaw. And I was talking to John Mueller, he reviewed this deck, and he basically said, John Mueller is in the search team at Google, and he said it's not true, but I've tested it, it is true. It filters things. So what you do, if you don't do this, then use the API and build your own connector with your own data store, right? So if it pulls everything without putting a filter on, you can filter afterwards and you'll have all the data. Important. Or alternatively, use branch tools. I absolutely love this. Like, it shows you algorithm changes and everything, and I think it's about $20 a month, which is that cheap. And you don't send the data to them, they just give you the visualization on your own data in BigQuery. Right? Now, who uses Bing Webmaster Tools? Ah, well done, there's one. So Bing has done something really cool, because normally you need to verify Bing. What you can now do, you can just go there and say log in with Google. And once you do that, it imports all of your sites, or your site you have in Search Console, and it verifies it automatically. So I don't get why not more people are using Bing, because I'm just gonna rave about Bing. How cool is that, right? So Bing will give you all of your pages that are 404 or 5xx with the backlinks, right? Normally you need Ahrefs, SEMrush, link research tools, or whatever, Majestic, that kind of tool set. But it's here for free, right? You can see count of links, status codes, everything, right? So you get broken links, you get data on 486 and 586. This is the URL. I don't think it's supposed to be live, yet it is. So you use freedomainalerts.com. It monitors your SSL expiration, monitors the domain expiration. This is a dangerous one, of course, if this happens. And then last but not least, the crawling tools. Who of you have used crawling tools? Quite a few. Probably Screaming Frog, right? Yeah. But there are some other ones which are free. So, you can use alphacrawler.pro. You get some ads, but it can crawl a website and will give you loads of feedback on it. You can use Sitebulb for free for 14 days, the full version. So if you want to do an audit on your website and get a lot of feedback that you can fix, you can just download Sitebulb, use it for 14 days, and then maybe buy it, whatever, if you want to, right? Or you can download Screaming Frog, and you can use a not fully functional version, but pretty good for if you have less than 500 pages. which most startups and scale-ups probably won't have, so you're good. And then I stayed within time.
This is not what I signed up for. This is not what I worked on browsers for 20 years for, to make browsers great, to build shit like that. This is just insulting to the end user. And we keep doing it. 20 years ago, I wrote an article or a training course called Unobtrusive JavaScript. Write JavaScript that is not in your way. So the definition was that we only use JavaScript to enhance the functionality that's already given, to make it more convenient. And JavaScript can be used, but we should never rely on it because it's an unreliable technology. It can break in all kinds of things. 20 bloody years ago. And what that all boils down to is a thing called YAGNI, which is you ain't gonna need it, which is an atrocious use of the English language, but it comes up with a nice acronym. And a proper acronym, like you're probably not going to need it in the next near future, so don't do it yet, is a far too long acronym, so that's why they didn't use it. Because the common developer approach is that we try to actually predict the next steps. We want to scale to infinity, we want to build the thing that we never have to do again. We're lazy, we want to do things once and then never ever do it again. So we write some code, then we make the code generic, meaning we allow anything in and actually put everything offer various output with an API and a documentation. So we don't just write the function, we make the function usable for other developers, and we allow all kind of nonsense to come in as well. Then we make it perform better by making it unreadable and actually making the computer do the things for us rather than just letting the computer do this. And then we check it for security issues if there's time. We don't not necessarily do that, but if there's time, we see if there's a security or a performance issue in there as well. And then we offer as a package, library, framework, extension. Like we do the npm package, we do that one library that solves that Internet Explorer problem from 20 years ago, and we are going to be the winner developer because we built that package. The problem is that that happens in parallel with dozens of other developers who also built that one solution to end all solutions. So we end up with a package hell that actually has a lot of things that don't need fixing, but because we thought it might be in the future that there's random data coming in doing it. Let's take a look at some of them. isNumber is an npm package that actually has quite some heavy numbers. It's basically, what it does is this. It does random shit in JavaScript to see if it's a number or not. So this probably, some of them was like old browser engines or old versions of V8. So this is what it does. That's the whole source code of the thing. And it has 70 million downloads a week. And it has 2,369 other packages dependent on it. 70 million downloads a week of that thing. Why is that not cached? Why is it being loaded all the bloody time? This makes no sense. And it's actually somebody analyzed that in their product, and they actually said like, okay, let's not do a require isNumber, but just put that few lines of code in our product and use it that way, because it's not going to change anytime soon, is it? And what it means is the estimated traffic over a week went down from 1.5 terabyte to 1 terabyte, just by not relying on that one package. And we rely on thousands and hundreds of packages all the time. So this is where all our traffic goes that we pay money for. Another fun one is isodd, which returns true if the given number is odd and an integer that does not exceed the JavaScript maximum safe integer. So here's the source code. Math apps of the value, and then it checks the isNumber is integer, is safe integer, and then n modulo 2 is odd. This is nonsense. This should not be in the package. This should be in your test suite. This should be the thing that you test for, not the package tests for. Because every package testing for that means computation overhead again. Now, the functionality here is the n modulo 2 equals 1. Of course, there's also a package called isEven. Can you guess what this one does? No, it doesn't do a demodulo, but it actually requires only isodd one and actually loads the other one that way. So it returns not isodd. Which and get more and more traffic that we have. Another package that I found in our test is this one, which is the beginning of the tutorial how to build an NPM package. It does nothing at all. Nothing at all. Really, like, it doesn't even console log anything out, it exports nothing. And it has like 26,000 downloads a week, I think, because its name is Dash. How does that get into production? Well, if you install packages on NPM, you do an npm foo. If you install it globally, you do an npm -g foo. If you put a space before the G, you install the Dash package and the package called G, which also exists. And if you do that in your CI/CD, it does that every single time it creates your package of your whole application. So this is how the whole traffic of the Dash package comes around. So these two things are the installation there. So when I started as a web developer, I wrote an index.html, I linked to a CSS and a JavaScript, and I built something cool. Starting a new package nowadays or a new project is basically get the right editor with the right extensions, because if you don't use a Pixel or you don't use Visual Studio Code or WebStorm or something, you're not a real developer. Then set up your terminal with the right font and the cool dot files, install the framework ghidul.js with bundler.io, go to the terminal and run package stuff -g install. Don't look at the fun warning messages and don't worry about updating the dependencies, because that's fine too. Doesn't work, go sudo, because then all the cool kids are, so make sure that that one actually works. And don't bother with the size of the modules folder, because everybody else has bigger ones anyways. And learn the abstraction windfarm.css, because it makes you so much more effective than CSS. And then use the templating language funsocks, because it's better than HTML, and check out the amazing Hello World example that you wrote an hour later. This is how we build these days. We have like, oh, because that scales for Facebook, so you should use it as well, right? Let's think about a simpler web for developers. Some facts. Browsers are constantly updated, every 4 weeks. Even Safari is good by now. All the browsers that are horrible are dead. Don't worry about them anymore. The web standardization process is much faster than it used to be. We don't all need to build the next killer app. Build something that people want to use. Build something that people need to use. I was very disappointed when COVID happened, because half a year before we said that we're going to have contact lenses that can tell us if we got diabetes. And going to be like, AI will solve everything. And then it was like, oh my God, we got a pandemic and we have to count who's been vaccinated and who hasn't, and who's got the disease and who hasn't. That could be a spreadsheet. No, let's build a $10 million app and actually put that on every person's mobile phone and then discard it a month later again. Our goal should not be to optimize our developer experience. Everybody does that. Like, use that, your developers will be more effective. Our goal should be to satisfy visitors using resilient products. Don't show me a loading page. Show me when something went wrong that there's an error. Please reload yourself. A simpler web for users is the same thing there. Browsers are damn good at optimizing the user experience. The reason is that browser makers, like I used to be, are actually measured on how fast their browser is and how much memory it uses. So we actually make the thing better for your end users. Operating systems allow users to customize the experience to their needs. Like, they can put the font up bigger, they can make a high contrast look and feel. They might just listen to your website because they're blind, and it's up to you to cater to them in the right format. You should always value that effort and build on top of it. So let's optimize what you control. What your users end up getting is in your hands. Send lots of semantic HTML, it cannot break. Don't worry about the size of that. That gets cached, that gets minified, don't worry about it. Use the newest setup. Servers can help you auto-optimize. Use the right formats, ALIF, WebP, image-generative, image formats that make sense. Pick your servers where the users are, and not somewhere in America and then wonder why it's slow. That's actually a really bad idea. And don't understand the great helper library, maybe then don't use it. So take off those old band-aids, those old helper libraries that we've been using. There's lots and lots of jQuery still on the web, all of it now a security problem and a performance problem. Remove polyfills and libraries. If it fixes things that aren't an issue anymore, bin it. If it makes things more convenient, but this has a platform native equivalent, bin it. If it's only used in one interactive part of your app, load it on demand, not up front as the bundle. No, you don't need it yet. Not every one of the users will go to that part of the application. Browsers do great things. They keep the history state, they allow for interception and reload, they tell you when a connection fails, and they cache and preload things. So they allow for bookmarking and for jumping into where they used to be. Okay, this was all the session data that we had in our videos. And this is basically where we tested the videos, that they had the right speaker and the right stage and these kind of things. This is all details and summary. There's not a single line of JavaScript in that. That actually does, HTML does that for us already. This is what the source code looks like. Forget browser delays having an impact. Forget that actually Internet Explorer exists. Don't worry about it too much anymore. And spend more time testing. What about? Hang on. Okay, that's the idea. So it's 2 times in 20 minutes. I was doing far too fast now. So great, I can now slower again. Hey, excellent. So spend more time testing, less time to invent the web. The thing that I always had to fight for was resources for user testing. You're like, oh, people are going to complain when it's broken. You're like, no, they're going to other people's products when it's broken. So that might be not the right thing to actually do that. So instead of reinventing the web, instead of just rebuilding these popover APIs, instead of building these like disclosure elements that we have there, what we do is actually just use them, and then we have time to make the product better. What about AI? We talked about that earlier. So I love that. Let's take a selfie like the humans do, because they look really, really human. I mean, we had that earlier, like I'm going to try that now as well. Hey, glasses, what do? I make you see things because you're old. So yeah, I'm not too happy about that. I worked on HoloLens. I now see these smart glasses, and of course the first thing that came out this morning, somebody used the glasses to do analysis of people on the train and actually saw their name and telephone numbers and actually invaded their privacy with their glasses on. So this is great stuff. That's always like the future of computing, and I think there's a space in there where we need to innovate in this environment. But I'm kind of done seeing $2,000 to $3,000 hardware being binned a month later or half a year later and not getting any updates anymore. This is just not a good thing for us as developers, and it's not a good thing for us as humans. Because AI is costly. Making an image with generative AI uses as much energy as charging your phone. And we are not aware of that, because we go to DALL-E and we keep asking it to do more photos and more photos and more photos. This is actually really, really bad. The amount of energy wasted on these cool new AI things is a very, very bad thing for the environment. Microsoft just reopened a 3-mile island nuclear power plant just to power their AI needs. And I'm like, what is this, the 80s? I grew up in the 80s. We had nuclear power plants that exploded. We had like Russia invading other countries. I don't know, that's not going to happen again. But like, it's just really bizarre that we're back in those spaces where we think like we can waste energy just for cool innovation rather than thinking about it. When I worked at Microsoft and I worked with Google and Amazon, there was a big thing about like, we're going to be carbon neutral in the next 5 years. Sometimes 2 years, sometimes 3 years. They all are going like, oh, we're going to be the greenest company on the planet. And right now, all of them underreported the data center emissions by 662%.